As Ocean Optics, we were pioneers of miniature spectroscopy, helping to usher in a new era in optical sensing. Today, as Ocean Insight, we partner with customers in evolving and exciting ways. We've enjoyed a front row seat as spectral technologies have migrated from research labs to industrial settings.
People are looking to kind of capitalize on spectroscopy or on spectral imaging to understand more about their process. Maybe it's a biopharmaceutical process, looking at endpoints or looking at reaction progress.
We are not just a spectroscopy company. We offer that full solution, but we're able to provide not only that solution, but the software behind it, the mechanical mounting behind it, and all the different aspects that a customer would want to see in a solution.
Additional support includes testing and evaluation, system engineering, and algorithm development.
We have a robust machine learning backend that we apply in industrial situations that can really make the difference for the customer who's not wanting to stare at a spectra, but really wants that red light, green light answer, or really wants a determination of concentration or something else, and not just a spectrum. And so we have that full stack of spectrometer all the way to system, all the way to answer. There's nothing more energizing to our engineering team than providing a successful solution to customers in a variety of industries, whether it's pharma, chemical, manufacturing.
Visit us at oceaninsight.com.
Our mission and purpose is creating a safer, healthier, cleaner place for everyone every day. Everything that Ocean makes is made here by hand. Part of what we thought about in designing the space is we wanted a very open and transparent space so that you could walk and have a conversation with a coworker regardless of department, and togetherness is really what was important, just making sure that everyone had access to everyone. The other part of it is creating opportunities and spaces to think. So we've got some little collab areas where you see a couple of chairs in a corner with a whiteboard. That's really what the space is for, is to promote thinking and promote collaboration and folks getting to spend time with each other.
Teamwork, high performance, and helping our customers exceed their goals, right? Everything we do points toward that. For the most part, we control everything. We control the flexibility of the product. We know what we want to make, when we want to make it. There's not too much that we need to outsource.
From the production standpoint, we looked at the overall space and said, what happens in every step of what we do, from when we order a product to it arriving at the door? And we actually went through a Kaizen event that drives that efficiency into the way the facility is designed.
The new layout of our assembly floor and manufacturing, it's going to increase our velocity and our throughput. We have to continue to grow in order to satisfy our customer base. Our customer base is constantly evolving and growing. We enjoy the work that we do. We value the customers that we serve, and we like working with each other. I want to create a work environment that is fun. We need a building that allows us to have fun.
It's just a very vibrant facility, and I think it's reflective of the type of work that we do and the type of people that we are.
Are you ready to unlock the unknown? I'm here to unbox an Ocean Insight spectrometer so you'll know what to expect when you receive yours. So with Ocean Insight, we like to unlock the unknown, and that's exactly what you're going to be able to do with your new spectrometer. One of the most important things to look at is this device setup and registration. This information is going to help you get started with your spectrometer, including giving you an idea of where to download your software from and how to get your device registered and protected for long-term care. The very first step you'll need to take is making sure that you install the software before you connect the spectrometer to your computer. This is a very important step to make sure that you have all the drivers installed on your computer before you connect your spectrometer to it. On the other side, we give you some information on how you can protect your new spectrometer, in addition to accessories and where to find your global sales and support. Inside of the box, you're going to find the paperwork, and this paperwork is going to give you information on your serial number for your spectrometer, as well as your wavelength calibration information. You'll use this information if you need support or to register your spectrometer on our website. We also provide a discount for an online purchase of a fibers, and then on to the good stuff. Your new spectrometer. In this case, this is a flame spectrometer, our workhorse spectrometer, great for all types of measurements. To talk to your spectrometer, we also include a USB cable. The USB cable is going to plug into this port here on the side. And the other thing you'll see here is a nice reminder of when you can send your spectrometer back for recalibration. We recommend annual calibrations just to make sure your wavelength accuracy is as good as it can be. Once you've installed your software and connected your spectrometer to the computer, the next step will be to get light into your spectrometer. And to do that, you're going to connect your fiber to the SMA connector on the front of your spectrometer. What's exciting about this slit assembly is the user can actually change that themselves, and we offer a range of slit sizes to enable you to reconfigure the spectrometer as needed for your application. So if you don't remember anything else from this getting started video, it's absolutely critical that your first step, once you've opened up and inspected your package, is to make sure that you install the software before plugging the spectrometer into the computer. It's as simple as that. Install your software, plug your spectrometer in, hook up your fiber, and you're ready to go.
In this video, we'll demonstrate how Ocean Insight products can perform a basic absorbance measurement. We'll also guide you through basic absorbance measurement procedures in OceanView software and share simple tips to ensure best results. For this application, we're going to set up an absorbance experiment. have allowed our light source to warm up as recommended in the light source manual. And now we're going to set up an absorbance experiment to engage the absorbance wizard. We're going to go to the Ocean View icon and click on that and select Absorbance. Select the absorbance only and click on Next with our reference solution in our cuvette holder. We're going to adjust our acquisition parameters, integration time, scans to average, and we're going to adjust our integration time with the reference spectrum. It's about 80 to 85% of our spectrum of saturation level, which is indicated by this blue horizontal line. So we can adjust our acquisition parameters such as integration time, scans to average, and boxcar values. We want to make sure electric dark is enabled, and then we're going to select Next with our reference solution in our cuvette holder. We're now going to store a reference spectrum. Once a reference spectrum has been collected, you will see it on the reference spectrum preview, and we're going to select Next. Now we're going to block the light entering the spectrometer bench and store a background. And then we're going to click on Store Background Light Bulb. And we've captured a background spectrum. Now we click on Finish, put our sample in the holder, and select the Absorbance Graph tab. And we can see an absorbing spectrum of our sample. This is how to walk through an absorbance setup. For more on absorbance measurements, visit the Knowledge Hub section under Support at oceaninsight.com.
In this video, I'm going to show you how to make a reflectance measurement. As a sample application, I'm going to show you one of the most common applications that's used for reflectance, and that's a color measurement. The components that we're going to use for our reflectance measurement are our Ocean HDX spectrometer. This one is configured for the visible NIR wavelength region, which is ideal for the color measurement we're going to be making. We're also using one of our tungsten halogen light sources, the HL2000. This is perfect for those color measurements with lots of energy in the visible and NIR wavelength region. Of course, the most important part of our setup is going to be our reflection probe, and this is going to enable us to couple our spectrometer and our light source to our sample for our reflectance measurement. The other accessories that we have here are our reflection probe holder, and then we have our reflectance standard, which we're going to use to take the reference for our reflectance measurement. In this case, we're using a Spectralon standard, the WS1. The first step in our setup is going to be to plug in and get our light source ready for our reflectance measurements. So first, we're going to plug in. We've got a shutter, which will enable us to take our dark measurement without turning the light source off. We have a nice warmed up light source, and if we turn it off, then we're going to need to let it warm up for another 20 minutes before we use it. On the front of the light source, we have this screw which will enable you to adjust the light levels. So if you have saturation in your spectrometer, you'll be able to decrease those light levels to avoid saturation. The next thing we're going to hook up is our spectrometer. We'll connect our power cable and then our USB cable. Next, we're going to add our reflection probe. What you'll see is we have one end of the probe that has a common end and has our ferrule. This is the part of the probe that we're going to use for our reflectance measurements. The other end of this assembly has two different fiber legs. We're going to take our light source leg and we're going to connect that to our light source. The spectrometer leg is going to go to our spectrometer. One thing to keep in mind is that these are glass fiber optic cables, so you want to be mindful not to bend them or twist them too much, or you could break the fiber optics inside. We can then use a sampling accessory like our RPH-1 reflection probe holder to enable us to make either specular measurements, where we're looking at reflection at 90 degrees, or diffuse measurements, which we're looking at reflection at 45 degrees. You need to make sure that the distance and the angle between your reflection probe and either your reference or your sample remain absolutely consistent throughout your measurements. Last but not least, we're going to need a reflectance standard for our measurements. In this case, since we'll be doing a color measurement and a diffuse reflectance setup, we're going to be using our diffuse reflectance standard. It's very important when choosing your reflectance standard that you pick a standard that has a level of reflectance that's very similar to the reflectance you're expecting from your sample. We are ready to start making our measurements. So the next step is going to be to start our OceanView software. You're going to go to Spectroscopy Application Wizard to find the Reflectance Wizard, which will help you get your setup into reflectance mode. So we're going to pick the reflectance option. We recommend sticking with the active acquisition, so no changes needed here, and you can just click Next. Next, we're going to set our acquisition parameters. And these are going to be the parameters that are used to determine how much light gets into the spectrometer and even to help improve our signal-to-noise ratio. The first thing that you're going to need to do is adjust your integration time. At 100 milliseconds, which is the default setting in the software, we are completely saturating the spectrometer. How would you know that? We have a flat line that goes across the top of the spectral window, which is indicating that the spectrometer can't see any more light. It's completely saturated. So what we're going to do is adjust our integration time to get that spectrum into the ideal range for our measurements. To do that, we're going to place the probe onto our reflection standard. So we're going to click the automatic button to help us get our integration time. It will set it automatically for us just below that blue line. This is going to give you your best performance. The next two settings that we have in our acquisition control panel is scans to average and boxcar. And these are two settings that we highly recommend because they're going to improve the signal to noise ratio for your measurements. In this case, at such a short integration time, I can do lots of scans to average. I'm going to start with 25, but I've done as many as several hundred, depending on how quickly I need to make the measurements. Next, we're going to set our boxcar smoothing value. And in this case, whatever value we set in the software is going to average pixels on either side of each pixel. So for example, if I pick a boxcar setting of 5, which is what I'm going to use for these measurements, that's going to average 5 pixels on either side. The result is that we get some degradation potentially in our resolution, but it's going to give us a big improvement in our signal to noise ratio. The next step that the wizard will ask you to do is to store a dark spectrum. We're going to close the shutter on our light source so no light is getting into the spectrometer. Once you've collected your dark spectrum, the next step is to turn on linearity correction. We're just going to place a check in that checkbox, and that's going to give us the most linear data that we can get out of the spectrometer. We click Next to collect our reference and our dark spectra. We're already all set up for the reference spectra here. We just need to make sure to open the shutter on our light source so that we're illuminating the reflectance standard. We're going to click the light bulb to store our reference spectrum. Once that's been stored, we're going to click Next. We're going to close our shutter again so we can take a dark measurement. We're going to click the light bulb and we're going to finish the wizard. We're going to open our shutter again, so we're illuminating our reflectance standard. And for a standard reflectance measurement, we're ready to go. You've done everything you need to do. Now you're just going to place the probe onto your sample and collect your reflectance spectrum. For color measurements, we're going to run through our color wizard now to specify the specific color parameters and other details for that measurement. We're going to open up the wizards by clicking here, and this time we're going to pick the color option. Since we've already got an outstanding reflection measurement going, we're going to go ahead and use existing processing. We have the option, as you can see here, of choosing from several different quantitative color values that we can output in the software, as well as picking our observer and illuminant. Then we're going to click Finish. Using this, we can actually see in CIE color space where our colors are falling. And what you'll see in the software is changes in the chromaticity diagram as we look at different colors. To make the measurement, all that we're going to do is place our probe holder directly on the sample that we want to measure. And as you see in the software, we can see changes in the color values and also in the chromaticity diagram. As we change to a different color, again, we can see how the chromaticity diagram is reflecting the color that we're actually measuring. Whether you're looking at color consistency, matching paint colors, we're actually getting quantitative values that will enable us to ensure great consistency. So what we've gone over today are the critical steps required to set up your diffuse reflection measurement. So we covered setting up the software. Don't forget to warm up your light source for 15 to 20 minutes. We've talked about measuring your reference, measuring your dark, getting into reflectance mode. And in this case, we took it a step further and actually went into a color processing mode to get quantitative color. For more information on ocean products, reflectance, or anything else, please reach out to us or visit us at Ocean Insight online. In 1989, Ocean Insight invented modular spectroscopy. And now we're proud to introduce you to the next generation of spectral sensing, the SR2. This is the next generation of modular spectrometers at Ocean Insight. It's designed to be a robust workhorse spectrometer that can fill many different types of applications. We went out and found a new detector not available in any other spectrometer. We combined it with state-of-the-art electronics that will enable you to get better measurements than you've ever made before. The performance improvements that you can expect to see are a flatter spectral response across the entire wavelength range. This means that your data in the UV will be just as good as your data in the NIR or in the middle of the wavelength range. The SR2 allows for integration times as fast as 10 microseconds while maintaining low noise measurements and a signal-to-noise ratio of 380 to 1. All of this performance is packed into a compact and affordable spectrometer footprint. Pre-configured models are available with entrance slits in widths of 5 micron to 200 micron, providing users with a range of optical resolution and signal throughput options. Thanks to the low noise performance of the SR2, you're able to see peaks which were previously hidden in the noise. This means that you're going to improve your detection limits so that you can get down to lower levels, maybe even trace level concentrations of your sample. The SR2 spectra have beautiful symmetrical peaks. Those narrow peaks are going to be very helpful to ensure that you're able to get good data for your particular sample. The SR2 excels in high light applications like laser characterization, plasma monitoring, or absorbance of biomolecules like DNA, RNA, and protein, as well as for plasma monitoring, where the peak symmetry that we see from the SR2 is going to give you far superior measurements than what you see with comparable spectrometers. And it gets all of its power over USB, making it a great spectrometer for field research. As with all Ocean Insight products, the SR2 is backed up by decades of experience in the spectroscopy market by the originators of the modular spectrometer.
Over 30 years ago, Ocean Optics introduced the smallest spectrometer to the market. It ushered in the era of modular spectroscopy, allowing critical measurements to be taken at the sample location, a true Big Bang moment in the world of photonics. Spectroscopy found footing in areas never before considered. Now, Ocean is excited to announce the next leap in possibilities is here with the Ocean ST microspectrometer. At roughly the same size as a golf ball, the ultra-compact ST is our smallest and most affordable spectrometer, unlocking new possibilities in many applications and device integration. Don't let the small footprint fool you. The Ocean ST delivers full spectral analysis at a performance level comparable to larger and more expensive spectrometers. And this little spectrometer is jam-packed with features. It has excellent spectral response below 300 nanometers, high-speed spectral acquisition, high signal-to-noise ratio, and a rugged construction ensuring reliable performance. The accessibility of the Ocean ST makes it the entry point to realizing the benefits of spectroscopy in scientific research or manufacturing. Available in 3 configurations, the ST covers ultraviolet, visible, and near-infrared wavelength measurements for whatever your application needs. For high-quality data or when working in low-light situations, the entry slit is customizable to optimize your throughput and your resolution. The ST is a versatile platform that covers a broad range of applications from DNA absorbance to color characterization and countless other traditional broadband spectroscopy measurements. These spectrometers are designed and assembled in the United States. We use a state-of-the-art electronics and optics platform to deliver incredible performance customers have come to expect from Ocean Optics. Each Ocean ST also includes Ocean Direct, a powerful cross-platform software developer kit with an application programming interface that allows you to optimize spectrometer performance and easily write custom software solutions to control automated data gathering. For more than 30 years, Ocean Insight has partnered with leading innovators to take on the world's biggest challenges using modular spectroscopy. The ST continues that legacy with an unflinching commitment to help you unlock the unknown. The only limitations are your imagination. The ST microspectrometer is available today.
At Ocean Insight, we get that not everyone understands spectroscopy or even how a spectrometer works. That's why we started the Ask campaign, so you could ask us anything. Why does spectrometer slit size matter? Is spectroscopy right for my application? Can I send in samples before investing in equipment? Our team of experts are here to answer questions for you, so don't be shy. Go to oceaninsight.com/ask and submit your questions today.